Good morning to all. I am Mohan, Department of Mathematics. Here we are seeing that the lot of orthogonal matrices we are discussed in, in this previous slides. Here we are discussing about the rotation matrices. See, why with that rotation matrices very important? Because the rotation matrices are orthogonal matrix that the representation rotation in space, that they are characterized by their determinant being 1. So here the then that the matrices are characterized by their determinant being 1. See, first of all, in this rotation around x-axis, that the first row of in this matrices, that is the 3 by 3 matrices. In this first row and this matrices 1 0 0 0 cos theta minus sin theta, 0 sin theta and cos theta. This is the 3 by 3 matrices. Then the rotation around y axis, that cos theta 0 sin theta, that is the first, and the second row 0 1 0, and then the third is minus sin theta 0 cos theta. In this way, that z axis is cos theta minus sin theta 0 sin theta cos theta 0 0 0 1. So here the matrices, the x axis 1 0 0, and then y axis around the y axis 0 1 0, around the z axis is 0 0 1. And this way that the values of another, that is cos theta minus sin theta cos theta sin theta minus sin theta cos theta, and then cos theta minus sin theta cos theta. So this way of the rotation matrices is always the identical matrices. The standard matrices are always the inside. That is called the standard matrices. That standard matrices will be created on the identical matrix, and then the basics following matrices, that 1 0 0 0 cos theta minus sin theta, and then 0 sin theta into cos theta. So here the given picture of that, the rotation basis, the theta omega, the cap, and then the value of r, and q cap is equal to r. So here the value of x-axis and y-axis and z-axis, that is the inside of the identical matrix. Then the reflection matrices, that the reflects of x-axis and the y-axis. So reflection matrices, it's the orthogonal matrices that represent reflection in the space. So here in that space, that characterized by their determinant being minus 1. So already we discussed in the previous slide that the reflection matrices are orthogonal matrices that represent reflections in the space. They are characterized by their determinant being minus 1. So in this reflection across the x-axis 1 0 0 0 minus 1 0 0 0 1, and then the reflection across y-axis, that is minus 1 0 0 0 1 0 0 0 1. So in this across the reflection across the x-axis and the reflection across the y-axis, there is the value of the same, but that reflection is the first point is the minus 1 comma 0 comma 1. So that point will be very indicated in this reflection of matrices. In this case, that is reflection across y-axis, the very important case. So in this reflection matrices is always the represent to the reflection only. So for example, it is called 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. that the reflection matrices. So reflection of matrices are orthogonal. Thank you.